Hi everyone, and welcome to my lecture about the transport theorem. The transport theorem relates the time derivative of a vector observed in a rotating frame to that in an inertial frame, or one which is non-rotating and non-accelerated. In other words, it is a vector equation that describes how the time derivative of a vector changes when observed from a different reference frame, especially when one of those frames is rotating. So dA over dt underscore b denotes the time derivative of A as seen in the rotating frame, and omega is the angular velocity of a rotating frame. The transport theorem is used to relate motion in different frames, such as when analyzing the motion of objects in rotating systems, such as satellites or aircrafts, as it allows for the conversion of measurements taken in a rotating frame to an inertial frame. A concrete application would be to relate the velocity or acceleration as measured in a rotating frame to those measured in an inertial frame. So the physical meaning of all of that is that the change of a vector observed in an inertial frame has two contributions. That is the change as seen from the inside of a rotating frame and the change caused by the rotation of the frame itself. Now, the derivation of a transport theorem goes as follows. You have a generic vector A made up of its components AX, AY, and AZ along the unit vectors IB, JB, and KB. Now, we want to take the time derivative of A as seen from the inertial frame, knowing that the body frame made up by the unit vectors IB, JB, and KB is rotating. By applying the product rule, we get what is at the bottom, and we can see that there is a natural split between the first three terms and the last three terms. The first three terms represent the change of A as seen from the inside of a rotating frame, while the last three represent the contribution of the rotation of the frame to the time derivative of A in the inertial frame. So that rotation is captured by dI over dt, dJ over dt, and dk over dt. And each of these terms is actually equal to the cross product between omega and the respective unit vector. Now all you need to do is to factor out omega and you will get the equation for the transport theorem. That's it for today. Thank you very much. See you next time.